Hello guys. Yeah, let's start our session today. So today we are going to start the third unit, intro part. So let me open the PDF. So actually we might know what is the meaning of combination circuit and what is the meaning of sequential circuit, right? So let me explain briefly about that. Yeah. So you can see here that here this is a combinational circuit. Okay. So the combinational circuit having inputs and it will generate outputs. So this is a simple sequential simple combinational circuit. Okay, so let's coming to the sequential circuit. The sequential circuit is nothing but simply we will have n number of inputs and it will generate n number of outputs, let us say. So again the outputs are given to the next state. So that is nothing but these outputs are again given input to the memory, so as like a feedback. So okay, so again the outputs are given inputs to the memory as like a feedback. Okay, so this memory will store the data which is present here and then here. Let us assume this is an adder, right? So 0 plus 0, so here we will get sum is 0 and the carry is also 0, right? So both the zeros from here 0 will be populated to the memory cell, and then from the from the carry also it will populate the 0 to the memory, same as like that. Okay, so these two let us assume, okay, these two bits of memory will store in this memories unit, and then it will be given to the input as an to the same inputs. So from the memory again it will be given to the inputs to the serial adder. Okay, this is an example to the sequential circuit. Okay, now let us go to our PDF. Yeah, so here in the sequential circuit memory unit is present, and then combination circuit there is no memory. Here in this combination circuit the inputs and outputs are present but no feedback. So here also the input and output is present, but the always the output is depending upon the input variables, right? Isn't it right? So always the output variables are again depending upon the input variables, because see, whenever if you change any inputs over here, so again the outputs will be carried out to the memory again, and again it will be given to the input, right? So that's why the inputs are sorry the outputs are always depending upon the input. So that is why it is an sequential circuit. Okay, so coming to here, so combination circuits are easy to design, sequential circuits are comparatively harder to design. So combination circuits are faster and sequential circuits are slower than combination circuit. So example is parallel adder and serial adder for sequential circuit. Okay, so these are the two diagrams for those combinational and then sequential circuit. Okay, I think you got it right. Okay, so let me go to the second topic. Open SR. Yeah, yeah. SR latch using NOR gates. So it's very easy to design SR latch. Okay, so let me give brief intro about this SR latch. Okay, so S is nothing but set, R is nothing but reset. Okay, so whenever if you give any two different types of input, let us assume 0 0 or 0 1 1 0 or any two. Okay, so you need definitely you need to get uh, opposite to the another input. Let us assume q is 0, right? Let us assume q is 0, then q bar you need to get 1, definitely you need to get. So opposite outputs you need to get over here. Okay, so let us assume s is 0 and r is 1, right? Let me give here s is 0, r is 1. sorry, r is also 0, right? Okay. So in this case, if the both inputs are 0, so you can, let us assume, this r is populated over here. Okay, I am going to send this r 0. Okay, this 0 over here. So this 0 will be populated in this r gate, sorry, NOR gate. Okay, after then there is an NOT gate, right? So if the 0 will be populated with the help of r gate, sorry, NOT gate, then we'll get an 1, right? So again the 1 will be populated over here. So 0 1 the 0. Okay, so 0 again, NOT gate, 1. Okay, sorry, I think I have given a wrong information. Okay, let me give one more time. So 1 will, for example, 0. Okay, 0 NOT gate, 1. 1 is again populated to the second NOR gate. Okay, 1 plus 0. Okay, 1. 1 is not 1. When we transfer the data from NOT gate, then it will be 0. So that is why I need to put here 0. So in this case, q is 1, q bar is 0. Okay, so let us assume, okay, let us assume now I have forwarded this 0 with this OR gate. Okay, with this NOR gate. Now I will populate this 0 over this OR gate, OR and NOT gate. Okay, so let us think. So for example, so 0 will be populated over the NOR gate. Okay, and NOT is there, right? So 0 will be 1. The 1 again inputs to here, right? So again this 1 and 0. 0 1 ja, sorry, 0 plus 1, 1. So 1 and then it is NOT gate, right? So we'll get a 0. So 0 and then 1. So for this case we got two, for this case we got two outputs, that is 1 and 0, 0 and 1. When we populate 0 at first time, when we populate yes 0 as second time. So let us assume this case. Okay, 0 and 1. So let us assume 0 and 1. I will take green color. So 0 as yes, 1 as r. Okay. So here in this case r is 1, right? So we need to, r is 1. So we need to make this NOR gate as high. Okay. So I am going to populate this 1 through this OR gate. Okay, OR and then NOT. So here it will be 1 and then so NOT will be 0, right? So again the 0 will be populated over here. Okay, so 0 here 0, right? So 0 plus 0, 0 only. So 0 NOT get 1. So you'll get q as 0, q bar as 1. So let us assume the second case 1 and 0. Okay, so I will take care of, okay, 1 and 0 is nothing but s is 1, r is 0. So for this case, which one is high? The second s is high, right? So I will populate this s through this NOR gate. So 1 will be populated over NOT gate. So not, it will change to 0. Okay, so this 0 will be transferred over here to the first NOR gate. So here also 0, the input also 0. So 0 plus 0, 0. So 0 NOT get 1. So now the data will be 1 and then 0, right? So in this case, okay, let us take the last example. Okay, sorry, I have forgotten this is the one. Okay, 1 1. So for the last case, let us take brown color. Okay, so 1, I think it is bit confusing, right? Okay, let me take this color. So 1 and then 1. So 1 1, right? So 1 1 will be, both are high. Okay. So now let me transfer any one of the case. Okay, let me transfer R as 1. Okay, R. So this as high, after then NOT gate. So 1 will be transferred as 0. So again 0 will be copied to the second NOR gate. Okay, 0 and here 1. So 0 1 0 plus 1 1. So 1 NOT gate 0. So here you can able to see, right, 0 and then 0. So this case is not acceptable because it is, so Q and Q bar is then quite opposite to each other, but we got the two outputs as 0 and 0. So this case is not used. So if it is both 0 0 or 1 1, so this case is not a perfect combination. Okay, so this is not used. You got it, right? So whenever if you see any one or anything, any set or reset is one, okay, just populate the data with help of from the NOR gate. Okay, from the NOR gate, then you will get a desired output. So these are our desired outputs. So these two are called as memory. Okay, these two are called as memory. So this is an quite opposite, and then this is a NOT gate. Sure. Okay. Let's take another case. So that is an SR latch using NAND gates. Okay, so don't forget this is an NOR gates. NOR is nothing but addition. Okay, so that's why I have added over here and then I applied NOT over here. Now let me take NAND. Okay, SR latch using NAND gates. Let me save it. Okay, so here you can able to see SR latch using NAND gates. So here this is an one NAND and this is a NAND. Okay. Here there is an NOT gate. Okay. This is a NOT gate because it is having only one input and then it is producing one output. Okay. So in this case, so if the enable is 0, do you know, right? So SR latch having only enable. So there is no clock. Clock will be for flip flop. Okay, so enable will be activated only for latch. Okay, only for latch. So now, so if the enable is 0, enable is just like an power supply. Okay, if the enable is 0, the complete circuit will be off. Okay, so that's why I have taken 0 0. Let me take the first condition, enable is all 1. Okay, so that is nothing but our circuit is in positive state, that is in the power supply has been given to the circuit. So let me take 0 0 as a first condition. Okay, 0 0 as a first condition. So here I will take 0, here also I will take 0. So 0 0 not get, when you transfer the data from the 0 0, it will be copied here. So 1 1. Okay, 0 will be transferred via NOT and it will be 1. So again 0 will be transferred via NOT gate and again it will be 1. So now, okay, so in this case 1 is a high and this one is also high. You can activate any one of the NAND gate. Okay, now I will activate this NAND gate. So one, it will be activated this this AND gate. So one will be passed through the NOT gate, that will be 0 right now. Okay, so 0 will be passed over here, passed over here. So 0 1 is 0. Okay, so 0 again passed via NOT gate, that will be 1. So this case I got it 0 and then 1. So now you pass the second one. Okay, this second one activate via this NAND gate. So 1 will be here. So 1 NOT gate 0. Okay, 1 NOT gate 0. So 0 will be again passed out here. So 0 1 is 0. Okay, so 0 NOT gate 1. So 1 and 0. So this is nothing but memory. Okay, Okay, let us take this case 0 1. So 0 and then 1. So what will happen? 0 1. So when we pass through the NOT gate, it will become 1 and it will become 0. So which is the high? So this NAND gate is high because this is 1, right? So we will activate this NAND gate. Yes, NAND gate. So yes, NAND gate. So 1 will be passed over here, and then one NOT gate will be copied to 0. 1 will be passed over NOT gate, it will be 0. Again 0 will be passed over a second NAND gate. So 0 0 ja 0. Okay. 0 0 ja 0. So 0 NOT gate 1. So Q is 0, Q bar is 1. Now let us take the other condition 1 and 0. 1 and then 0. So 1 will be 0. So 0 will be 1. So now this NAND gate is activated. You need to activate by seeing this 1. 1 will be activated. So okay, 1 will be activated, right? So 1 passing through this NOT gate will become 0. Okay. So again the 0 is passed over the second NAND gate. So here we have 0, right? So 0 0 the 0. So 0 will be passed via NOT gate and again it will become 1. So 1 and 0. Our outputs are 1 and 0. Now take the last case as 1 1. So as 1 and then 1. So in this case 1 1 will be passed over here and then it will become 0 0. So now both the NAND gates are low. So now you can pass anyone. Okay, I will pass this 0. So 0 NOT gate 1. So 1 will be passed over to the second NAND gate. So 0 and then 0. 0 1 ja 0. So 0 will be passed over NOT gate, that will become 1. You can able to see here 1 and then here also 1. So this case is not satisfied because this Q and Q bar will be quite opposite due to set and reset. Okay, if the switch is on, definitely the other switch will be definitely off, like that. Okay, if it is 1, then the other output needs to get 0 only. But in this case we got 1 and 1, so which is not satisfied. Okay, so I will write it as not used. Okay, so till here we have covered SR latch using NOR gates and SR latch using NAND gates. Okay, till here. Thank you.